In 2003, 16 years ago, some of us were lamenting the lack of building going on within the club. And at the time, there was a line following contest and a maze contest. And we knew we had robots in the club, but they pretty much just were built and shown one time and just sat on the shelf. Thank you. And we wanted to do some kind of contest, but you know, the maze and the line following had these struck things that you had to maintain and put together and keep up with. And we wanted something that was simple. Now, at the time, we met at the Castro Middle School in the library, and there were tables. And we thought, oh, let's do tabletop soccer. We thought, oh, we could put nets around the table, and that way if the robot fell off, it'd catch it. But no, that's setup. That's something that had to be maintained and so on. And that's when it was born, the TableBot. TableBot's a robot that survives, lives, and plays on a table, or pays the price. Now, the vision is tabletop soccer, okay? And that is non-trivial, as Bill Benson would say. So how to get there? Well, you get there in phases, and that's where we decided to do this during 3 different meetings in June, August, and October. And that gives you 2 months between builds, and we do phases. Phase 1 is build a robot goes from one end of the table to the other and back. Phase 2 is have it push a block off the edge of the table, and phase 3 is to have it push it into a block at the end, have it push it into the shoebox at the end of the table. Now, we don't define the size of the table, the color of the table, the size of the robot. I've seen some awful big shoeboxes over the years, and it's not a contest, it's a show, okay? And so here's one that I've had for years, and I've tried to refresh it. And this evening I'm going to demonstrate phase 1 and maybe phase 1.5. But anyways, I just want to say about these challenge meetings, without a deadline, nothing happens, okay? Sometimes with a deadline, nothing happens, yes? But without a deadline, definitely nothing happens. And so even though you don't get the results that you want, you put time, energy, and effort, and you move the ball a couple of feet. You know, and it gets you set up for the next one. And that's the great thing about this club is every month we have show and tell. So every month you've got a place to come and show what you've built. No other place in the world is like that. And so you should really take advantage of it. So without any further ado, here is Buggy doing phase 1. So here's when you really trust your robot.
Are we going to go for 4? Oh no, he fell.
But wait, there's more. So this is actually a great example of subfunction architecture where simple behavior stacked on top of each other exhibits the illusion of intelligence, okay? Okay. Okay, here I am finishing phase 1. You can applaud now, thank you. So phase 2 is to push the block off the edge of the table. Raphael, how you doing? And so I'll put this block here. Basically, when he sees it, he'll stop, and he may move towards it, and he may or may not push it off. But that's kind of where I am. And the point in this is that, you know, without the challenge meeting this evening, like no work would have been done with, hey, John and John. All right. Gang's all here. Let's see if he can find the block now. You know, finding something is much more difficult than avoiding things. Good evening, Wayne. So good to see you.
Yeah.
Wayne Bramlett, ladies and gentlemen. Oh, this is close. It's not a contest. Wait, that isn't quite right. He should have actually, you can applaud him. He should have actually noticed it, so let's give him another try. How many robots we got out there this evening? Raise your hand. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I know some of you got 2 or 3, so yeah, we got our 20 robots. Very fine. Applaud yourselves here. Okay, so here comes the block. Oh, see, he sees it. Okay. Okay. Never mind. Okay, do we have any other table bots out there this evening? Table bots. Yes? Marco? Come on down. Marco Waltham, ladies and gentlemen. Now, this is a real robo star here, I'm telling you.
Can't sign the book.
Thank you.
Level whatever.
Yeah. You want to hold the microphone? Marco Waltham.
Okay, you probably have seen this guy before. Dexter, a combination out of Lego, Mindstorm, motors, some extra down-facing IR sensors, the first version of the Pixicam, and basically Raspberry Pi, and one Arduino on there as well. And yeah, so let's see if it can still do phase one. So first it tries to calibrate the IR sensors. So it takes a moment.
Also, we don't specify you have to go lengthwise.
I tried to find the middle of the table, but the motors are not quite as accurate as I would have liked, so sometimes.
There is a phase 4. It can't fall off. It just still needs to function when you put it back on.
That's phase floor, I believe.
Mark? Yeah, please.
So eventually it should stop.
The batteries run out.
No. Unless I really play with it and basically leave it running longer than 60 seconds, it will turn off the operation after 60 seconds. So let's see if they can do phase 2. And it doesn't see. I tried it over there, and there I saw the block and it saw the box, but that's the problem with the Pixicam. It's so light sensitive that it doesn't see it. It's not even on.
Yeah.
Okay, not so much luck today.
Can't you retrain it right now?
I could on the laptop. So let's try this one more time. But I don't have the Pixie monitors software here on the Pi. I have it on the laptop. Now it sees it. And of course the screen is on the back, so.
It worked at home.
Yeah, no, it even worked over there.
Yeah, it's what it's.
Yay!
Yeah, I actually do have a little screen on there, so I know what it's actually seeing or thinks it sees. So that displays really help in trying to debug stuff. No matter if it's LEDs or a little screen or something. Now I feel lucky. So that's supposed to be a phase 3. Okay, that's it for the tabletop.
Al Margos, ladies and gentlemen. You can applaud. Al has literally programmed everything in the world, right, Al?
Yeah, more or less. This will be real quick because this is the traditional non-functional HBRC tabletop robot.
Good for partial credit. Microphone.
This actually is an entry for the HBRC Historical Society. This first competed at, I think, challenge number 3. This is a basic stamp 2 sharp 15 IR sensors. I did manage to get it. It's got the 4 sensors. You probably can't see it from where you are, but it's detecting. I've got my, again, debugging lights. You always have to know what your robot's thinking and deciding. And that works. And I actually had one tread spinning, but there's some broken pins on this old controller. So I've got to decide whether I'm going to refurbish it for historic reasons or just keep it all off and replace it with a modern whatever. No life.
Ralph Hipps, come on down. Ralph Hipps of the Amazing Maze Challenge. One of the Ralphs.
All right, so this is Bile. I'm going to try just doing level 1 first, which usually just works. Pray for me.
Thoughts and prayers.
Yes, thoughts and prayers.
You should explain how you get your names.
Sorry,
You should explain how you come up with your name.
the names for the bots, yes. All my robot names are evil. Mostly they start with B. This one's Bile. You know, not quite evil, but disgusting at least. And he's the first of the Digesticons, a series of bots I'm working on. And he has a cousin. Okay, level 1. Yeah, he's got a twin, an evil twin brother I'm working on. Looks just like him, only with slightly different stuff. And his name is what is his name? I keep forgetting. Oh yeah, Reflux. Anyway, yeah. So we're gonna see if I can do level 2 with this approach. But the lighting, you know, is always fun with the pixie cams. So we'll see what happens. And I don't think he's gonna see it. So what I might have to do is demonstrate how you calibrate the pixie cam on the fly. Well, he's doing level 1 again.
So when you're doing level 1 and the camera is moving back and forth, is it actually using that information?
Well, that's a great question. So, the thing on top is actually a quote-unquote LiDAR sensor. It's like an infrared rangefinder. But he's just sweeping the table, looking for the edges and the end of the table. That's all that's doing. When the pixie cam's down here, and he's just fixed,
and looking for the lock.
Is it passive or IR?
Sorry?
The passive or IR type situation? Is it the passive IR or is IR?
It's active IR, so it's
Detector.
got an emitter and a detector.
Gotcha, just checking the
Yeah, just
technology.
looking for all that good stuff. So I realize this is taking a little bit of time here. I'll try to speed this up.
All right, with any luck. Oh, jeez, never mind. Time, that feeling.
I thought that was the one.
I thought I had it too. He sees the block, but then he's supposed to turn to the block.
Probably because camps and.
That's probably
Blame it
it.
on Cam, blame it on Cam. Oh, we got orange
Yeah, I got an orange shirt on. You
t-shirt.
throw me off. You never know. I just don't know. Yeah,
Instead
that's,
of a yellow flag, it's turning towards a yellow shirt.
right.
All right, Ralph, are you ready? Ralph, knock. Say affirmative? You say affirmative. Affirmative? That's your third last.
Yeah.
Thank you, sir. Ralph,
All right, so this little robot has a bit of a story. Some of you have probably seen it before. I've tried to do the maze with it about a year ago, I guess, probably the same event a year ago. But of course, then I got distracted with it. It used to have a Raspberry Pi and an ARM processor on it. But of course, I got distracted. As some of you are aware, there was a lot of talk about FPGAs going on around the club for a while. So I ended up getting a little FPGA board from Bob Smith. And tried
Bob
to,
Smith.
Is he here today? He's right here. Yes, he Bob. Decided to implement a lot of the electronics on the FPGA. So got a pretty good way on doing that. But then, of course, you always get distracted, and I got frustrated with how complicated modern computers are, and I yearn for all of the simplicity of the days gone by. So while messing with my TRS-80, I decided for my FPGA, I was going to put a soft core on. So I chose to put a TRS-80 in the FPGA, and then use that to drive the robot. So this is the TRS-80 video screen the team uses.
I wrote the Pascal compiler for it.
Yeah, so I can unplug it now. Now, because of our wonderful power company, I had no power for the last 3 days, so unfortunately have not got it finished. But if I'm lucky, it'll at least drive to the end of the table and stop.
So are you saying you put a 6809 emulator on there?
It's a Z80, so it runs a Z80. It's a full TRS-80 Model 1, Level 2 with 48K RAM, 4 disk drives, the whole works on one little $30 FPGA board. So this program is written in TRS-80 Microsoft Basic. So I think, if nothing else, this will be the first TRS-80 powered robot demonstration. There it is, it's right. Oh, really? And it stopped at the edge. So, like I said, I didn't get a chance to do it.
Phase one half.
So it has oops, a gripper that should be able to pick up a ping pong ball for when I get to do phase 3. The cliff sensors, has the line sensors that you can see the bars on the bottom are actually reading the bar sensors. So this is outputting the PWM to the infrareds, and then the analog, you can see that it can detect the edge of the, so for line following, one day I can try to do line following. It has a couple other sensors for detecting objects on the table for level 2 and 3, but as I said, didn't have any power for 3 days, so I didn't get the rest of the state machine in that written. But, hey, is that a level a half if it just gets to one end of the table?
But yeah, phase one half.
All right.
It's good. It's not a contest, it's just a show.
So So if you, I mean, the great thing about the TRS-80 is if I want to know how much I spent, I can bring up VisiCalc, or if I'm bored, I can play my favorite Scott Adams text adventures on there. They're all loaded onto the robot right now.
Historical and hysterical.
Yeah.
Steve, question?
No, just, I just wanted to say that, like, somewhere back in 1980, 15-year-old me is just standing up on a chair in a court.